Hello guys, welcome to my channel. Today's video is about Java data structure and algorithm course, and I am going to implement array-based set data structure. If you have not already subscribed to my channel, please subscribe and promote the content. Let's begin. Introduction of set data structure. Set is a linear data structure. Set stores unique elements of the same data type. Set can be implemented using an array or a linked list. Array can be fixed array size, or we can use a dynamic array that will grow its size or resize it itself whenever it requires more memory. Sorted set maintains ascending order of its elements. All the elements must be unique and they are in ascending order. Set contains special functions, for example, union, intersection, difference of sets, complement of a set, disjoint sets, and proper subsets. These functions are not available in other data structures, so these are special for the sets. Time complexity, insertion. Because set can be implemented using different data structures behind the scenes. So if we implement array-based data structure, so it will have a best case O1, and O1 happens if the set is empty. Then we have average and worst case scenario. Linked list based set has O1 when the set is empty, On when the insertion is carried out at the end of the set. So we have to navigate to the end of the set and insert the new element. We can achieve O1 runtime for insertion at the end if we add another instance field to keep track of the tail node within the set. So we can use that tail node and insert instantly at the end of the set, and we can achieve O1 runtime. It all depends on the design pattern that you will adopt to implement the set. In the case of insertion into a sorted set, the runtime complexity will be O(n) square, because you always have to navigate in the array, locate a location, and then have to shift the elements towards right to make a hole within the array, and then insert the new element there. So O(n) is the complexity for searching for the correct location, and O(n) again we have to shift the elements, so it will become O(n) square. Runtime for the average and the worst case of insertion within the array, sorted array. In case of sorted linked set, this insertion will be carried out within O(n) time, where n is the number of elements we have to search to locate a correct location to insert the new element. Same way, if we are implementing set using an array, the deletion will be O1 in case the set has single element and removed from the front of the set. Otherwise, if this is not the case, the complexity will be On for average and worst case scenarios, because we have to shift the elements to fill the hole created by removing the elements from the underlying array. In the same case for linked list. If we implement set using a linked list, the runtime is On if the element is removed from the front of the set. In case of average and worst cases, they will happen when we have to search for the element. If element exists somewhere between the linked list, we have to iterate to locate and then remove the element, and its complexity is On. In case of using the additional field tail in the linked list, we can achieve O1 for the removal of an element from the end of the set, because in that case we do not have to iterate or traverse the linked list, that is storing the elements behind the scene, and we can directly access the last node and remove it. Search is sequential or linear for unsorted sets. no matter whether we use array based implementation or a linked list based implementation. So runtime is O1 if the first element is the search element or the search key. Otherwise, we have to use ON complexity in case of average and worst case scenarios. In sorted array based set implementation, if we are implementing array sorted set using an array, we can utilize binary search, which is way faster than ON, and its complexity is O log n. But this binary search is very hard to implement in case of linked list based implementation. So it is only useful if we are utilizing array for the sorted set. Accessing the size of the set is O1 always, because we can directly return the number of elements stored within the set. And print function O1 if there is one element, ON otherwise. In best and worst cases, n is the number of elements stored within the set. So print has linear runtime, that is ON. Thank you guys. That is all. Let's start the code. And again, if you have not already subscribed the channel, please subscribe. Thank you. Hello guys. I have created the application in NetBeans and added two classes. The main class is array set class that we will implement for the set data structure using an array and provide all the basic functions and set theory functions, and another class to test the functionality of the array based set. Let's begin coding. We begin with over array set class. Okay, so now what we need, a capacity for the array. Let's say private final int capacity, let's say 100. This is our capacity, and array to hold values, private int data, and this is an array, and an index to keep track of current element, private int index. Okay, now we need a constructor to allocate the memory. Public array set default constructor to set up memory, array memory. Okay, we can also pass capacity variable parameter from here and initialize the array to that. And we can also use a fixed size array, or we can also add a function to grow the array if needed. So I am going to implement grow function also. This data is equal to new int and capacity. This is our initial capacity. This dot index is equal to, let's say, 0. Okay, that's it. Now let's define functions first so that we can implement it later. So first function, add, public void add. Let's return the boolean type to indicate whether the addition is successful or not. Int value. Function to add an element to the set. Okay, what is the condition? Number 1, capacity. Number 2, uniqueness. Uniqueness is the feature of the set. Set only contains unique elements. So in case of failure, we return false. Okay, now let's define grow function first. Private void grow. We grow this function or grow the array if we need it. Grow the array size and keep the existing elements. Okay, so we first copy the array, int copy new int, and we can store data.length, copy the elements. I'm not using built-in functions, that is because it is better we write our own code to learn the programming. Otherwise, there is the java.util.arrays class that has lot of functions that we can use to copy and recreate arrays. New array, copy elements for int I 0, I is less than index I plus plus, and copy I is equal to data I. Now reassign data is equal to new int and index multiply by 2, double the size. Okay, now copy back. We can also assign this array to this one, but it is better to do a deep copy. For int I 0, I is less than index I plus plus, data I is equal to copy I. That's it. Our array is resized to the double the capacity. Okay, now here public boolean is full. If this array, this data set is full and there is no more capacity left, so we have to resize the array. Return index is equal to data.length. Check if the set is full. Indicate set is full. Okay, now if public boolean is empty, if the data set is empty, if set is empty, indicate set is empty. Return index is equal to 0. Okay, now let's check. First case, set is full. If this dot is full, so what we need to do is grow the array. This dot grow, that's it. Now assign the value or store the value. This dot data index plus plus is equal to value, and return true. Okay, we also need to check the value. Check if the value already exists within the set to maintain uniqueness of its elements. Okay, so what we need, public boolean find. So int value function to check whether a value exists. Value to check and return indicate exist or not. So return -1 or return false, mean does not exist. For int I 0, I is less than index I plus plus. If data I is equal to value, so we have the value, return true. So we have the value, so we return true. Okay, now we check it here. If let's say find value, so we show the error as out the value already exists. We can also throw an exception like illegal argument exception and return false to indicate the value is already there in the set and we cannot add it. Now the remove function. public void public int. So we remove the element. Let's say we make it boolean, remove int value. If we successfully remove, we will return true. If it does not exist, we return false. Remove an element from the set. Value to remove, and return true if removed, false otherwise. Okay, so first of all we need find index. Int index is equal to -1. It is just an arbitrary value to check whether we have the element to remove. Otherwise we return -1, we return false. For int I0, I is less than index I plus plus. If data I is equal to value, so we set the index is equal to I and break. This way we can find the index of the element to remove. Okay, now shift the elements to fill the gap. For int I is equal to index, we can check here if index is equal to -1. This means element does not exist. We return false. Okay, now shift the elements. I is less than data length and -1 I plus plus. Why -1? Because we need to go up to n-1 elements. Okay, now data I is equal to data I plus 1. Overwrite previous element. Okay, this way we fill the gap. Now return true and also update index minus. Okay, this is how we remove from the set and return true or false based on the value removed or not. And array has to be filled. The hole must be filled to remove the element. Okay, now let's add print function. Public void print the set. If this dot is empty, just output a message, the set is empty, and return from here. Otherwise s out, and let's say first element %d data 0. Now rest of the elements. For int I0, I is less than index I plus plus. Start with 1 because we already used the first element. Now sf, and we can print with comma %d and data I. At the end, s out and close the bracket. That's it, guys. This is print function. Now the size of the set. Public int size. Just return index. Get the number of elements. Return number of elements. Okay, guys. Now the important thing. The actual these functions are almost common in every data structure. Now we have to implement set theory functions. Okay, let's make space for set theory functions. Okay, now we need I think 5 or 6 functions. First function is public set union set other. So we will return a new set that will be the union of two sets, current one and the one passed in the parameter. Public set intersect and set other. Next function, public set difference set other, and other function is public set, and we return the complement set other, and the function public and boolean is disjoint set other, and the function public boolean, what operation is left, difference complement is proper subset set other. Okay, let's write comments for these functions. Okay, so this function create a new set that is the union of two sets, other set, and return union. Okay, create new set, let's say union is equal to new set. Okay, now what we will do, insert all the elements from current set, insert all the elements from other set. The set maintains uniqueness due to this condition in add function. We already wrote this condition, if the value exists within the set, this will not add. Let's remove the output because it can output lot of output statements. Okay, so we return union array set. Okay guys, let me change the name. I made the class name array set instead of simple set. Okay, now let's begin with first array. For int I0, I is less than index I plus plus. So we simply do union dot add and data dot I. We do the same thing for the other set, int I0, I is less than other dot index I plus plus, union dot add data dot I, other dot data dot I. That's it, our union is ready. This will add all the elements from first set, and this will add only those elements that are not already in the set, in the union set, and at the end we will have a union of both the sets. Now the intersection, we can copy this to save time, and let me put some comment here. Create a new set that is the that has elements common in both sets. Okay, other set, and return intersection of two sets. Okay, copy this here and we will change the logic. Okay, Now, instead of running both the loops, we can do the if condition. If other dot find data dot I. If data dot I, this ith element from current set exists within the other set, we take it. And add it to the intersection. Let's say intersection. Okay, copy and paste it. That is over intersection. This function, this loop will iterate all the elements of current set and check whether that element exists within the other set. If it does exist, it is a common element, so we keep it in the intersection set and return the intersection set. That is our function. Now the difference. Function to create new set, that is the difference of elements from A to B. It means all the elements from A that are not in B. Okay, so we start. Let's copy and paste it here. Change the name. Difference. Difference is like a subtraction. Okay. Let me change. Insert only common elements from both sets. Insert only elements that are not in B from A. Okay. So, if not, we use a loop that will iterate all the elements from the set A and check if that element exists within the other set. We do not use it. If it does not exist within the other set, we keep it as a difference. That's it. This is the logic. This will create A, let's say D is equal to A minus B. Okay, now the complement. Function to create a new set, that is the complement of A. Okay, how we create the complement? Let me show you. Other is the set whose complement will be created. Return the complement. Okay, so there is a universal set. Let's say 1, 2, 3, 4, 5, 6, and set A or other set. So it is 2, 3, 4, and let's say 5. So the complement will be set 1 and 6 because these are common elements. So we remove these elements and only keep the elements that are not within the other set. So this is the complement of other set from the universal set. So how we will achieve this? Let's copy this one. We use the same logic and let me change the okay, and this will become complement set. Okay, update the reference. Okay, insert elements from A that are not in B. It is not A, it is universal set U that are not in A. So it will become the complement of this set. It will become, this is how we write the complement. Now the disjoint sets. Check whether two sets are disjoint. So what is a disjoint set? A disjoint set are two sets that have no common element. Okay, so A is equal to, let's say 1, 3 and 5, and B is equal to 2, 4 and 6. These are disjoint sets. Okay, other set and return indicate disjoint or not. So we start by first element. For elements from the first set, if I is equal to 0, I is less than index I plus plus, if other dot find data dot I. If there is any common element, any one single common element, those sets are not disjoint. Return false. So reach here, that means there is no common element between the two sets, so we return true. Now the subsets. Let's copy this one. Check one set is the subset of other set. Okay, other set, and indicate if it is proper subset. Proper subset means all the elements should be in the other set. So for int I0, I is less than other dot index I plus plus. So if not find other dot data I, return false, and this is return true, means other is subset of current set. So if it finds any element that is not within the current set, so it is false. So guys, these are the functions for the set theory, and let's test them. Get back to the tester class and we create object. Array set, let's say A is equal to new set, and array set B is equal to new array set. Okay, now let's push elements. First set is 1, let's say 2, 3, 4, 5 and 7. Second set is, let's make 3 sets. Okay, 2, 4, 6 and 8. And another set, let's say 1, 2, 3, 5, 7, 8. Okay, now add elements. A dot add 1, 3 and 5 and 7. Okay, B dot add 2, 4, 6 and 8. Now C dot add 1, 2, 3 and 5 and 7 and 8. Now sets are ready. Okay, now let's check set functions. Okay, so set union. Let's make it set. Okay, so a dot union b. So let's print a dot print and b dot print and set dot print. Let's check the result. Okay, so these are 4 elements from A, and these are 4 elements from the B set, and their union is having all the elements. All these elements are unique already. Okay, let's try intersection. Okay, intersection set is equal to A dot intersection C. Okay, set dot print. Okay, let's print it. Okay, this is our intersection. So how it works? 1 is common with A and C, so we take it. 3 is common, we take it. 5 is common, we take it. And 7 is common, we take it. So only the common elements for the intersection. Now the difference. Intersection difference. Set is equal to A dot difference, let's say C. Okay, let's make it B because it has a couple of different elements. Okay, and print set dot print. Okay, only 2 elements are printed, 4 and 6. Let's check now. 2, both have 2, so it is not used. It is not stored in different set. 4, it is not in the C, so took it. 6, it is not in the C, so took it. And 8, it already there in the C, so remove it. So we have only 2 elements, 4 and 6. Now the complement. So set is equal to C. C is the universal set because it is bigger, have more elements. Dot C dot complement, and other set is A. So print set dot print. Let's print it. Okay, it's printed 2 and 8. So let's check. Okay, this is a universal set and this is A set that we going to find for the complement. So 1 is there, 3 is there, 5 is there, and 7 is there. 2 and 8 are not there. So we took 2 and 8 from the universal set, and that 2 and 8 are the elements of complement of the A. Now let's check disjoint sets. So disjoint. S out is A and B are disjoint. So A dot B and is A and C are disjoint. A dot is disjoint C. Similarly, S out is B and C are disjoint sets. B dot is disjoint C. So let's run it. Okay, so A and B are disjoint. Let's check them. A has all the odd numbers and B has all the even numbers. So they are obviously disjoint. Now A and C, they have common elements. 1 common, 3 common, 5 common, 7 common. And B and C also have common element. 2 is common and 8 is common. So they are not disjoint. False. And A and B obviously disjoint. Disjoint are the two sets that have no common element. Now the proper set. So proper subset. S out is a proper subset of C. So C dot is proper subset A. Similarly, we can copy and run it 3 times. B and let's say same set is always subset. So 2 is enough. Okay. This is C and B. Okay, let's run it. Okay, so A is proper subset of C. Why? Because all the elements of A are in the C set. B is not proper subset of C because it only have 2 elements within the C set, that is universal set. So guys, our functionality is properly done, and these are most and commonly used set functions. You can add more functions if you want. I am hopeful you can learn a lot from this tutorial, and this is array based implementation of set with the array resize function, and the array resize function will help accommodate more elements than the capacity of the current set. Practice, practice and practice. That is the only thing that will help you learn programming. Thank you guys. If you have not already subscribed to my channel, please subscribe. Thank you.